Right, next step. We made the reagents. I'm only by myself, so the proper order is that you work from clean to dirty. So we made the clean reagents. Now we're going to extract the samples. So since we have a DNA pathogen and 2 RNA pathogens, I need an extraction kit that can do both, or I have to do it multiple times. But the extraction kit that we use is the MagBeat extraction kit number 1. The cross states it's in use, it's not a new kit, it's in use. This kit can do both, it can do DNA targets and it can do RNA targets. So the device we'll be using is my trusty old RoboPrep machine. For this little demonstration I prepared a bunch of samples and I doctored them to give certain results. I have some poultry samples and I have some swine samples. These four are poultry, these 4 are poultry. These 4 are swine, but I'm going to do them twice. For swine, I only needed 7, so I'll take these 4 once and then the top 3 again, and then we can see what they yield. And they've all been doctored, and I might tweak them afterwards to yield certain results during the software demonstration, but I'll worry about that later. For the PRS kit, the PRRS kit, we have an additional control that helps us to determine if the extraction was valid, yes or no. For that, I need to make an additional control. Which is over here. I'll tell later what it is, and I need the reagents that go into the process control, and I have those over here. That's the stuff I'm going to need for this small demonstration. First things first, I need to prepare my reagents on the plate. The plate that we will be using is a normal deep well plate. Well, it's not a normal deep well plate, it has to be suitable to the device, but it's a normal 8x12 plate that can contain a fair amount of liquid. And I'll be using today, like I said, 8 poultry samples, 7 swine samples and 1 process control for the swine kit. So that's a total of 16. That's not by accident. These plates can hold 16 extractions at max. And I want to be a bit efficient, so I doctored it to match 1 full plate. I like always to help myself a little bit with a visual aid by just marking the half of the plate, so that way it's easier to count the rows that I need. It's perfectly fine to do this, you're not going to harm anything on the test. In order to prepare the reagents, we have a table that dictates the amount of reagents I need for a certain amount of extractions. Today I have 16 and I have a table here that dictates the volumes that I need. These are the volumes that I'm going to add to a tube. I have a tube. And I already named it lysis mix because that's what it is. That's what I'm going to use. I like using 50 ml tubes. I'm going to put this to the side because first I need to worry about creating the lysis mix. All right, let's take a look at the contents of our MagBeat 1 extraction kit. Like I said, this kit is already in use. I have a bunch of reagents that are included in the kit. If we look at the list, we have a lysis buffer, which is already pre-made, you don't have to worry about that. We have 2 washing buffers. When you buy this kit new, before using them, you're going to have to add ethanol yourself. But I already did this because this kit is already in use. So 2 washing buffers. I have magnetic beads, which are one of the core components of any magnetic bead extraction kit. I have proteinase K, which is an enzyme that helps in the extraction process. And we have something that we call carrier RNA, which is also part of the kit, which also helps with the extraction process. I'm going to put the stuff aside for the moment that I don't need, and I'll take it when I need it. And now let's worry about adding the right reagents, and I'm just going to follow the table that I have here. So my first component for 16 samples is the lysis buffer, and it's telling me that I need 5.4 milliliters of the stuff. I highly recommend, when you do stuff like this, using a pipette like this, which is a 10 milliliter pipette. It allows you to handle bigger volumes in one single pipetting step rather than having to take a smaller volume and having to pipette that multiple times. So in this case I need 5.4, so I'll just set it to 5.4 and I'll take a tip, which I had conveniently set to the side. I'll take the lid off the buffer and I'll just take the 5.4 milliliters. As always, take your time with this. So I've taken my 5.4 milliliters of reagent and I'll just add it to my lysis tube as my first component. And I've added it, and we ditch the big tube, or the big tip. I like to put to the side the stuff that I don't need. I don't need this anymore. So second component is isopropanol. And for 16 samples, I need 7.2 milliliters. So I'll just do that. I'll take my trusty big pipette again, set it, in this case, to 7.2. Here's my isopropanol. I never work from the bottle. I always work from pre-filled tubes to help with contamination issues. So I'll have my isopropyl alcohol over here. I'll take another tube or tip. I'll take the alcohol. Pipetting alcohol is always a little bit difficult because it likes to evaporate from the tip. So my advice is try to do this as quick as you can to prevent spillage. I'll add my isopropyl alcohol, ditch the tip. That's component number 2. Component number 3 is proteinase K, and for 16 samples I need 450 microliters. For 450 microliters I'm going to need a pipette that can handle that. So in this case I'll set it to 450. Set it to the side, and the proteinase K is contained in this bottle. We recommend aliquoting this. If you, when you receive the kit, it's covered with this rubber lid that needs to go. Make sure your gloves are clean when you do this. I'll take my pipette that has been set to the correct volume. I'll take a tip, as always, filter tip, and I'll just pipette the volume, as always, slowly. That's fine. I'll take the tube again, pipette. Done. That's component number 3. Component number 4, magnetic beads. I need 360 microliters. So I'll take my pipette again, set it to 360. And this is the component that I need, magnetic beads. I cannot emphasize this enough. You need to shake these, and you need to shake these well. When I give trainings like this, I always like to say, shake, shake, shake some more, and when you think you're about done shaking, shake a little extra. These things tend to settle in the liquid quite quick, so my advice is thoroughly mix them, and once you've mixed them, be quick with adding them. So they have been added. The volume for my pipette was already set correctly. I'll take the liquid, close the tube, and add it to my lysis mixture. Again. Almost finished. Final component, carrier RNA. I just followed the table, 54 microliters, so I'll set the pipette. 54. Here's the tip. Here's the tube. Remove the lid. There's no way of doing that without not blocking the camera, but it is what it is. 54. Park it there for a moment, and I'll just add it to the tube again. That's it. That's step number 1 of the extraction process, preparation of the lysis mix. Right, that was preparation of the lysis mix. Now let's add the needed buffers and reagents to the plate. So the buffers we're going to need are washing buffers, elution buffer, and we're going to add the stuff to the plate. To do that, I always recommend using something like this. This is a multi-step or a handy-step pipette that is capable of dispensing the same amount of liquid every single time. So that speeds up the process quite a bit. So the volume that I'm going to use for my first buffer, which is washing buffer number 1, is 800 microliters. So I'll take the tip that I need for this. I'll add it to the device, close it. There's a table on the back that is telling me which setting I need with this tip to get to 800 microliters. In this case, it should be step number 4. So I've set it to step number 4, which gives me 800 microliters every time I dispense the liquid. Let's open up wash buffer number 1. I just fill the wash buffer. These buffers contain quite a bit of alcohol, so it's always mindful to be a little bit quick about this. Right, so washing buffer number 1 goes to row number 2. And to row number 8 for the second set of 8 samples. I won't have enough after 1 row, so I'll just add more buffer to my tip. And now I go to row number 8 and I'll do the same thing again. This is why I have the stripe on the plate. It helps me to count the correct rows. And that's it. Since this plate is clean, you can put the excess of the buffer back into the vial. And I ditch the tip. All right, component number 2 is wash buffer number 2. Do the same thing. I'll add my tip to my pipette. Make sure the piston is locked. Take the buffer. And this buffer will be used twice for every extraction. So it will go to rows number 3, 4, and 9 and 10. So, second buffer, rows 3, 4, 9 and 10. So I'll start with row 3. It's the same process. I won't have enough for the second row, so I'll do it by refilling it. Then going to row number 4. And I repeat this process for the second set of samples on the other side of the plate. We're done with the washing buffers. We're going to leave row 5 empty because it's not needed for this extraction method. But we're going to need something to use to capture our DNA with, and that will be the or RNA as well. Our elution buffer, which was a bottle that I forgot to take from the kit earlier. So we need a different volume for this, and it's only 100 microliters. So I'm going to use the same pipette, but I'm going to use a different tip, which will allow me to select 100 microliters. And it's set to position number 1, so I'll set it to number 1 with this different tip. I'll open the bottle and I'll aspirate. I won't need much for this because it's just 100 microliters. Elution buffer, the tip has been filled with liquid. And now we go to row number 6 for my poultry samples. And we'll go to row number 12 for my swine samples in this case. Done. Next step. We're going to add the lysis mix that we prepared earlier to the plate. And in this case, we're going to need a different volume, and the volume is 748 microliters. So I'll just set it to 748. And I'm going to add this to rows number 1 and 7. Row number 1 for my poultry samples, row number 7 for my swine samples. And I've received your request to tilt the plate a little bit. Normally I would keep the stuff in my hand. Now I'm not going to do that. So you're going to have to bear with me a little bit. I'm going to do this reverse. And we go to row number 1 and we do that 8 times. Very important to mix the vial before you do that, which I already did, because the beads tend to drop to the bottom of the plate, of the tube. So we'll do this until we've done our 16 reactions or extractions in this case. Done. Final step. Final step. We're going to add the samples to the plate. The samples, like I said, have been doctored by me. They're designed to give certain values because that helps me to demonstrate the software. I'm just going to take 200 microliters of the sample, which are artificial, and I'm just going to add them to the lysis mix in row number 1 and row number 7. Like I said, I had 8 samples for poultry and I had 7 samples for swine. So I'll just take, we're not going to show all of these, I'm just going to take a few and add them to the plate, and then once I'm done with the poultry side, I'll get back to you to talk about swine. So let's do poultry first. Like I said, 200 microliters. And I'll take one of my doctored samples, open the tube, 200 microliters. When working with samples, I always try to open and close tubes away from my plate to avoid unnecessary contamination. And if you can avoid crossing the plate with a tube or a tip containing potential positive samples, I always recommend coming from the side if and when possible. So this will be sample number 1, which goes to well number 1. And I'll just add it. I'll do that one more time with sample number 2. And I'll keep doing that until I'm done with my 8 poultry samples. And once I'm done with this, I'll get back to you for the swine samples. And my swine samples are going to be used on the PRRS kit. And the PRRS kit contains the exogenous extraction control. And for the exogenous extraction control, I need to have a negative control that is also going to undergo the extraction process. And we call that the process control. So I prepared a tube here because you're going to have to create the mentioned process control. It's just a volume that is matching the volume of your samples. So I chose 200 today, so I'm going to add 200 microliters of either water or PBS. Any clean liquid will suffice. There is water in the kit that you can use. So I've taken 200 microliters and it's already in this vial. And now I'm going to have to add the process control, which is this tube over here. And this process control, I'm going to have to add 5 microliters of this stuff to this tube. And once I'm done with that, I'm going to come back to you. So very simple, add 5 microliters into this side. So now, second part, we're going to add the swine samples. But because the PRS kit uses an exogenous extraction control, there are 2 things different. One, the aforementioned process control, which is now a new negative control that will have to be extracted. We're going to add that to well number 1 in this case. 200 microliters, the volume is the same. So I'll just take my prepared control and I'm going to add it to well number 1. This process control will be used to judge the amount of potential inhibition in the samples while it's running. So there will be some math behind it, but our software will take care of that. Our software is not mandatory, but it just helps with the process. You can do all this without using our software, but if you can get it, then why not? Next step is we're going to add samples to the wells. But there's an exogenous extraction control, so the samples will also have to be used combined with the process control. So all the samples will get 5 microliters of this stuff as well. And you can do that before or after doing this step on the plate. Today I'll just do it after adding the samples. You can also add it to the extraction buffer if you want to do that, but in this case, because I also had samples that were not using it, I would have lost a lot of the process control. So today I'm just going to have to add it after adding the samples. Samples again, 200 microliters, nothing is different there. I'll start with sample number 1, which now goes to sample plate number 2, because the first one contains my process control. There's no real way of getting to that location without having to cross the plate anywhere. So if I have to cross it, I try to cross it in the row where it's going to be extracted anyway. So in this case, row number 2. And I'll just add the samples as usual, and I'll come back to you once I'm done with adding all 7 of them. I've added the samples. Now I need to add the same process control to the samples. 5 microliters, same as the process control. So I'll take my tip, I'll take the process control, and I'll add 5 microliters of it to each and every sample. So the first one for me will be sample number 2. I'll just go in there, mix it a bit, go out. And I'll repeat that 7 times. Final step, running the device. This process is not very long. I was explaining a lot, so it took a lot longer, but normally this is only a few minutes work. So now all I have to do is add my plate that contains buffers and sample, and for the PRS kit also the process control. I'm just going to add it to the device. So I'm going to place it on the left side in this case. Make sure that it's seated properly on the heating blocks. Check one more time. Also, we're going to have to add these combs to the magnetic rods, because if you don't use protective combs, your device will be ruined after running it, because you would have to clean everything. So we'll add combs, and they will go in like this. And since we have 2 rows on this plate, I'm going to need 2 combs. These are 16 samples. This device is called RoboPrep 32. The name implies it. You can run 32 samples if you want, which would mean having a second plate with 2 more combs. Well, that's it. For today, I only need 1. So that's it. I'm going to close the machine. Check one more time. And then we're going to select the proper protocol. This device can be programmed to run whatever you want, but in this case, I'm going to run Magbeat 1, because that's the kit I'm using today. All I have to do now is hit the play button, and I can come back once the machine is finished in about 45 minutes.